We now move to comparing two samples, two proportions, or two means, right? We take two samples and we're going to compare those samples, whether it's a mean or proportion. In Module 12.1, we're going to be comparing two means. And the way we do that, right, the two means of two different samples or groups, right, we want to compare them. We do that two different ways. We either can do that through checking to see if there is a difference. What is the difference? Let's estimate the difference between those two. And you do that by subtracting the means. Now we use the sample means again as an estimate for the population means. And we know there's variance in those samples. So again, this is why we need to conduct these tests, whether it's a two proportion Z interval, two proportion Z test, right, two sample T interval or two sample T test. It all depends upon whether we're comparing proportions or means. And then we do that through what we call a confidence interval, or which we've done in the previous modules, or through a test, a hypothesis test. And you want to pause and read these example questions. But again, notice the types of questions, whether it's a yes or no, or is it an estimate, or to find some value. That determines whether we have intervals or if we're doing tests, right? How much taller are men on average than women? That's an interval, that's a number. We're looking for a value, so that'd be an interval. We first look at the comparing of two means just by looking at graphs, right? Here's some data on COVID, cities in North America and Europe. Even though it says countries, it's cities. And you have a certain amount of cities. We found the number of COVID cases in July 2020. And you can see the distribution, both skewed because some cities really were off the chart. But when we compare the means, when you look here and compare the means and standard deviations, we can get a sense of North America had less COVID cases than Europe. And you can kind of see that because of the stacked bars are a little bit higher on these axes. So when you compare and contrast, you can see when we can compare them, it looks like Europe has more, right? The question though, is it discernible, right? Is it noticeable? Is it statistically significant? Maybe. I think it looks like it. The data's here. We have some outliers, but on average, this box is more than this box. So with that said, right, this is a way to at least look at it. Now we're going to do the actual, conduct the actual tests, right? Or create the intervals. And so that's what we do in the next few pages, where we look to see, right, a two sample T interval, because we're going to be comparing two means. We have two groups, people who took tests who were proctored and those who were left unproctored, and you're comparing those means, and we want to check to see if those mean differences are actually different, right? Based on the standard deviations, are the population means. Can we say all proctor students would be different than non-proctored students? And so we have the 5 steps still. Notice now, I just have a calculation that pops up, right? That calculation, and this first we're using interval, we're comparing the differences. Now, the calculations by hand are really complex. So what we end up doing is we end up using the ArtistStat or stat technology to calculate. You put in these data. So to compare those two means, we go to the ArtistStat, two groups, compare two means. And since I have all the sample data already, we can go ahead and enter that in. I have my own summary statistics. I think in this problem was the scores. So again, just to be thorough, we had the group 1, which was proctored, just call it PRO. And then group 2 is non-proctored. Sample size is 30 and 32. I entered the sample means and standard deviations. And again, it's this sample standard deviation which creates that standard error that gives us that variability, because this is just one sample, right? One sample from two different groups. And so that's what we have to use, and we get the number, we get a point estimate. So on average, we think there's a negative 3.97 difference, meaning that the proctored group, those who are being watched while testing, scored lower than the non-proctored group by 3. That's our point estimate. Now, our confidence interval says between negative 1427 and 6.3, which means that sometimes, because it's negative and positive, 0 is contained inside of this confidence interval. It's contained, it's inside of it. That means it's possible there's no difference, because sometimes, based on the variability, we may get the proctored group scoring higher than the non-proctored group. And that's what these numbers mean. It leans slightly towards the proctored group, but you could see those values right there. And that's what we have. And it was a 95% confidence interval. So we make sure we had that confidence interval there. And then again, that's what leads us to these values. Again, we're not hand calculating it. We are 95% confident that the difference in mean scores between them is between these two numbers. We conclude there's no difference, right, statistically between the groups because 0 is contained or part of the confidence interval. Fifth step, is it random? I don't know. It doesn't say whether it was random or not. They were taken independently, though, but we don't know if they were randomly assigned, so it's undetermined. And the sample size, yeah, it's large enough, right? And so we have questions. There's a lot of research questions that can emerge from that. But again, that's just the idea what the fifth step is. Again, this in blue is an important concept. This 0 is contained in the confidence interval. And when that's the case, that means we statistically say there's no difference.